DC-24.
323. I don't know exactly where they wanted it.
10,000 miles from the surface, Mariner 4's cameras came to life.
These signals came back, if you think of one element, one picture element, one sample of sound, of light. The rate at which these came in were from Mars was one of these per second.
Hey, there we go. There she goes. Yeah, that's data.
And so it took 3 weeks for our 20 pictures to come back.
Or the devil or the Mars picture interpreters. Yeah, Data's coming in, boy. What are you doing in bed?
There it is. I think we got some pictures.
The planet was not what they had expected. There was no sign of life here, no vegetation. Just picture after picture of a dull, flat landscape. It wasn't until frame 12 that the first features became visible.
What we could see were these huge craters, 300 kilometers, 200-mile craters across on Mars. Impact craters, and that meant that Mars was preserving a signature from its earliest times, 3-4 billion years ago. And so we had a major conclusion, stunning to everybody, from these very few pictures we got.
When the news filtered through to the Soviet Union, one man wasn't as surprised as his Western rivals. Craters were exactly what Viktor Safronov expected. Soon, Safronov's ideas were being discussed in the West, where superior technology allowed George Wetherill to take the accretion theory further.
I've called it the planetesimal problem. And it simply says you've got a lot of objects, small planets, moving around the sun in orbits. And what you'd like to understand is how they accumulate together to form large planets.
Wetherill's computers uncovered a terrifying period of planet formation.
What you actually find, if you do the problem with the computer, is that as they grow, they start to perturb one another into orbits which cross the orbit of another planet.
Soon the neat orbits of Safronov's army of planets became fatally disrupted. As they started tugging each other off course, the solar system became a kind of demolition derby. World-shattering collisions were inevitable.
George realized that it was sort of like a wild frat party. All sort of hell breaks loose in the inner part of the solar system. Things are swung around. Half the stuff is either hits the sun or gets thrown out to Jupiter, which can then knock it out of the solar system. It's a very violent, happening party.
In 1973, George Wetherill got the chance to test his ideas. Mariner 10 was on its way to Mercury. "78 million kilometers from Earth, and way beyond the scope of even the most powerful telescopes, the surface of this planet was a total mystery." After a journey that took in a flyby of Venus, by February, Mariner 10 was nearing its target.
Subsequently, though, however, I had the opportunity to be invited to JPL and sit in a little room up above Mission Control and see the pictures of Mercury as they came in. First pictures of Mercury started coming, and at first it was just sort of a fuzzy ball, and you could sort of imagine you saw craters. But after a while, it got closer and closer, and pretty soon it started to look just like the moon.
Mercury turned out to be the most heavily cratered planet in the solar system. One impact was so great that it left shockwaves set in stone on the other side of the planet. It was proof of the final stage of the accretion theory.
And I was just thrilled by this, you know. I knew they were there, but just but actually seeing them, that I've been thinking about all these years, and now here they are. From a look at it, made me very excited, and it also excited all these military men around. They kept saying, "Isn't that beautiful? It's just like a 52 drop in Nam."
Here then are the inner planets, the survivors of a life or death struggle. Mercury, Venus, and Mars, each bearing the scars of creation. But what about Earth? Surely our planet could not have survived unscathed. In the field, Hal Levison gets a real sense of the violence that rained down on the planets, including our own.
This hole in the ground was made in a matter of seconds. Despite being a very awesome sight, something that tells us that the solar system is still active and that things are storing into each other. It's a relatively small, insignificant hole in the ground.
"50,000 years ago, a 50-meter fragment of a world blown apart billions of years earlier slammed into the Earth in what is now Arizona. Here is startling evidence of the final stages of accretion. And accretion isn't finished with the planets, even now. Each shooting star in the night sky is an accretion event. A piece of space rock falling into the Earth. Daily, the Earth gathers in 100,000 tons of debris from space, most of it dust and small fragments. We walk through falling space dust every day of our lives. But this is small fry. Circling between Mars and Jupiter is a swarm of leftover parts from early, violent planetary accretion. This is the main asteroid belt. Several 100,000 of the largest have been discovered, cataloged, numbered, some named.